Hi, everybody. I'm really glad to be here. Can you see my slides now? I'm going to
Yes.
be talking to you about polar zonohedra and how they can be colored. And what you're seeing here is a piece that I've offered to the JMM art exhibition. And I'm really excited by the idea that we'll be able to go to Seattle and be there in person, imagine that, and see an art show and, circulate around. And I'm going to tell you about this shape and where I got it. I want to repeat my theme of whenever I put an idea out there, I hope that people will steal it and, adapt this shape in their own work. So I learned about polar zonohedra at George Hart's Bridges talk. It was the first talk. It got things off with a great bang. And I'm going to just explain to you what this shape is. It's a distinctive kind of polyhedron whose faces are all rhombuses. And to construct it, you start with like an umbrella, he describes it as, in this case, of 8 radial symmetric vectors, and they're all inclined at the same angle. So it's like you've got this umbrella with these vectors all inclined there. And then what you do is you successively add neighbors until the sums converge at the opposite vertex. So one thing you can imagine is you've got this umbrella of vectors all maybe placed at the origin. If you add those all together, what do you get? You get a perfectly vertical vector. So if what we're doing is adding successively, if you keep adding the vectors around, you will end up at a point that's directly above the one that you started at. Now in my diagram here, the thing is upside down. So I'm going to think of starting at the top with the vectors that are around this vertex. And let me just highlight in blue 2 of those vectors. And when I add the left-hand one to the right-hand one, I get that one. That's a new vertex. Now here is maybe the 3rd of those vectors in the umbrella, and I'm going to add that, and I get another vertex. So you just keep adding these vectors. The vectors become the edges. Because you're using parallel vectors here, you're going to get all rhombuses here. So that's how you construct these. There's one class for each n. So I showed you one with 8-fold rotational symmetry. This one, I believe, has 13-fold rotational symmetry. For a while, I was doing all 8, 13, and 21 to have Fibonacci numbers for absolutely no reason at all. And you can also have just a continuum of angles at the bottom. It's just a free parameter. So here's one where the angle, I believe, is 60 degrees. They're all inclined at, and that makes for a pointy shape. If you make that angle low, you'll end up with more of a pumpkin shape. And this one has 13-fold rotational symmetry and a high angle. And for this one, I pasted on a wood grain, and that gives sort of an impression of wiggliness, which I really like. In George's talk, he always, colored things with a solid color. He constructed a tiny library made from this shape, but that's a painted object. So I'm investigating the possibilities of pasting texture maps on these rhombuses. So here the pasting helps you see the spiral zones. That's, if you take one chain of rhombi that spirals around and goes from bottom to top. So the iterative addition required scripting. The description of this shape has an if-else statement, and depending on where you are, you need to use some kind of computer logic to add the vectors. So this was my first Python script in Grasshopper, and I was delighted that I didn't need to call for help, that I was able to make a Python script. If you don't know about Grasshopper, it's a programming language so that mathematicians can make shapes inside a computer design program called Rhino. Rhino was designed for architects, but it's kind of hacked for mathematicians by this Grasshopper interface. So the way it works is you a little element here. This is going to make a list of numbers 1 through 8. And there's this weird thing with it. Computers want it to be 0 through 7, and I want it to be 1 through 8. This is a widget where you can change it from 8 to whatever you want. This is the thing that is the Python script. And, I don't want you to look at the code, but this is just a definition for the vertices that uses the if-else statement, and the output are the 4 vertices of each rhombus. So I used a NURBS surface from 4 points feature, where you can put in the 4 points that are going to be the corners of a surface. In this case, I was giving it a planar surface, so it made a nice planar shape. And then I wrote this code so that it would make one of those spiral zones and then duplicate that by rotation. And then it's beautiful. You get to see the shape here. And this one happens to have a ceramic blue glaze pasted on it. This is to help you see what I mean by one of those zones. It's just, you know, following successively up in a chain of those rhombuses. So to investigate the artistic possibilities, this one shows what happens when you paste on something that has like different kinds of continuity with neighbors. Note that here, there's a cream colored thing on the edge with this neighbor, but a solid thing on the edge with this neighbor. So that with this neighbor, sorry, I pointed to the wrong place. So that creates something that looks like a chain going up and around those spirals. You can go for alternating colors. This is a photograph of stained glass, and this one's in Photoshop with Photoshop's ray tracer. Photoshop is discontinuing its ray tracer, and that's going to cause me a lot of grief. So if you have a favorite ray tracer that you like to use, I may be requesting assistance. It's also possible to alternate colors in a different way. This highlights those zonal spirals. This is the Rhino ray tracer. And this one, there are only 2 different kinds of material here, the blue and the purple, but the blue creates quite a variety of reflections in the Rhino ray tracer because those faces are all facing at different angles. So I know much better how to control the ray tracer in Photoshop, but Rhino has one as well. You can also like use both kinds of color alteration and get a checkerboard. And this has been the thing that has really delighted me the most in the last few weeks, is that this now is a checkerboard of different patterns pasted on here. And, you know, I just love going to town with those reflections and creating a surrealist effect by, you know, inserting a photograph of the lake in the Sierra Nevada that I love so much, and, you know, getting a little reflection off the lake and stuff like that. So if you know my work, you know that I've kind of shied away from greens. And so I was having a festival of greens here, and they come from, yeah, this is back to Photoshop. Let me speak just a little bit before I talk about the greens, about the patterns here. You see that these original patterns all have 4-fold symmetry, rotational symmetry. I made that with a kaleidoscope app from Peter Stampfli. I've got a blog coming out in the math values column. If you don't know about the math values column, I recommend it. It's new from the MAA. And they asked me to write an article about, gee, how would a person get started in mathematical art? And so I've written a description of this particular kaleidoscope. So I made 4 different patterns here and pasted them on. And the greens come from a really beautiful place. It's the Lakewood Chapel in Minneapolis, Minnesota. I don't know if anybody knows the Lakewood Chapel, but it's this beautiful Art Deco mosaic work. The day break and the shadows flee away around the dome there. So all you do is you put a fundamental dome triangle on this, and you see the pattern right next to you in another window. So I'm really enjoying making patterns and pasting them onto these things. I hadn't evolved quite this far when it was time to submit my work for the joint math meeting. I only got here, but I made a whole scene of polar Zonohedra. I call this the Temple of Zonohedra. And if you see the top, the dome of the temple is a 21-fold Zonohedron that has this wooden grain pasted on it. I've got a couple of wood grains. This right-hand shape has a wallpaper pattern pasted on it, and it turned out better than I would have expected, because when you paste wallpaper onto things that are being squeezed, it doesn't stay wallpaper, but it still stayed pretty. This green is one of my oldest wallpaper patterns climbing up around here. And because this does have facets, I'm getting these sharp reflections where the light hits right on it and reflects off to the viewer's eye. And then a thing I didn't mention earlier is that it's really easy to put piping along the edges here and put little balls there to create an ornate effect, maybe of sort of like a Fabergé egg. That's all designed in Rhino with Grasshopper and then colored in Photoshop. So then you knew that, I love to put chainmail on things. So I had to make chainmail on these Zonohedra. And I just love this thing. It's like, it's this weird ice skating thing, a Christmas ornament with its little shadow. This is done in the Rhino ray tracer. And it's, I'm still learning to use it, but this I think is my most successful one. What you do is you create one little circular, shape, or a shape with fourfold rotational symmetry, and then you place the rings using a little widget in Grasshopper that says, put this object somewhere else, and you can give it a pair of vectors, and you use the sides of the rhombs as basis vectors, and it just adapts them. So I really wasn't being clever there. I just found the right widget to put the thing there. Imagine if you took a zonohedron and peeled off the lowest vector vertex. I realized that I could make a surface from 4 points. So all I did was peel off the lowest one, and I made this. So, and put little balls on the edge. And of course, that's my Christmas tree prototype. Another thing that happens around this time of year is, I start to feel the pressure to make my Christmas card. So I realized I was making a tree here. And so if you're ready, as my final thing, I will show you my Christmas card for this year and see if you can see what I mean by this as my Christmas card. Yeah, we've got ourselves a nativity scene with, Jesus, Mary, and Joseph, and the little manger there, and the star as a polar zonohedron in the heavens. This is a photograph of stars that I had, and Joseph is colored in 3 colors. That's the way to do that. And that's my timer for 12 minutes. So I think that I will stop and invite your questions about this work. Oh, but wait, I wanted to also, just an hour ago, they delivered my Christmas cards. And so I've got the scene on the front and the ice skating chainmail zonohedron and Mary on the back. She's clad in chainmail with a ceramic zonohedron on the inside.
This is great. This is absolutely wonderful.
Thank you.
Very sweet.
A thing that I love is, at Bridges, people throw out ideas, and it really is fun if someone else picks an idea and takes it. So take this idea, someone, please find out what you would like to do with it.